Chapter 7, Section 5 is about adding and subtracting polynomials. A big part of this section is that we are going to be working and practicing with combining our like terms. So being able to look at these polynomials, being able to identify what terms go with what terms match what, and being able to simplify them so that they're maybe not as big, and being able to write them in a simpler form by combining those like terms. So in the past you've had to do this with just like x's and just like your numbers. Now what we're going to do is just kind of extend on that a little bit and have x squareds or x to the thirds. And so you're going to be looking for those like terms and getting them together. We're going to start with adding, because adding is easier than subtracting, okay? Now a lot of times what they might do is put the examples in parentheses. When you are dealing with addition though, the parentheses are maybe just there to kind of give you separation of the two polynomials. You don't really need them when you're doing the next step. So actually what I would suggest when you see an addition problem is just rewrite it without the parentheses. Then what I do is I start to look for my like terms. I see right away that I have a 5x squared. So I look through the rest of my list here and I try to see if there's any other x squareds. And I see this one that says 3x squared. So I'm going to end up putting those two terms together. So if I add them, 5x squared and 3x squared, you only add the numbers in the front. You're not going to add x squared and make that become like x to the fourth. Because we're not multiplying them, we're just adding. So x squared is like an x, okay? It's just representing like something in the problem. And so it's like x squared represents apples, okay? So I've got 5 apples and I've got 3 apples, and I'm trying to add them together, so I get 8 apples total. So we would write that as 8x squared. Once you're done, maybe just cross them off to kind of keep track of which ones you've already combined. Okay, then I look to see, all right, I got x squared, so the next smallest term would be just an x. And I do see one of those. There's only one. So I'm just going to write plus x. Cross that one off. And then you look for any regular numbers. And I see a -2 and a -7. Watch your signs here because they're both negative. You're adding them. -2 plus -7 would be -9. So your answer here would have been 8x squared plus x minus 9. Okay, so take a minute here and practice. Okay, so what I did is I saw the 3x squared and the 2x squared. Those are going to go together. The 2x is kind of standing by itself. And then we've got the -7 and the -2. And so I ended up combining these together to say 5x squared plus 2x minus 9. Now we're going to get into subtracting. Okay? For subtracting, they again are going to put your answers in parentheses. And this time it is a little bit more intentional, because you're going to have a minus sign in between them. And so the big key thing that I want you to do before you even start combining is that you distribute the negative through the second polynomial. So what that means is you're going to take that minus sign and basically think of it as a -1. And you're going to multiply that -1 to all the terms that are in that second set of parentheses. Okay? So for this one, you're going to think of this as being like a -1 here. You're going to distribute that into the 3x, into the y, and into the 7. So now I'm going to rewrite this. So I'm going to leave that 5x minus 2 alone because I didn't have to change that. But all of these terms in the second set, you're going to have to switch. And all they do is switch signs. So it's going to be a -3x minus y and then plus 7. Now I look for like terms. I see 5x and then minus or -3x. Those will have to go together. I see a -y by itself. There's no other y's. and I see a -2 and a +7. So 5x minus 3x, that would be 2x. That takes care of those. I always put the letters before any plain numbers, so that -y does need to come down next, and there was nothing for it to combine with. And then last we have this -2 or -2 plus 7, so that should be 5. That takes care of those numbers. You'll want to just be extra careful that you're watching for those negative signs. Don't just assume everything's plus and positive and that you're just adding everything together. So just really keep track of those negative signs. Take an extra step to check over what you're doing, and don't rush through these, because I know that sometimes these seem easy because you've added and subtracted for a long time. But sometimes when students get a little too quick about things, that's when those small little mistakes happen. Okay? Now there are 2 practice problems here, this one and this one, okay? And I want you to go ahead and try to do both of those right now. So if you need a couple minutes, I would pause your video here and try to do these 2 examples, and then come back, keep watching, and see what they should look like. So what you should have done for this first one, kept the first term the way it is. Make sure, though, that you distribute that negative in the second term. I always like to draw the arrows just to remind myself I have to do it to everything. So it became minus x squared minus 2x minus 4. Then I started highlighting my like terms. You know, if highlighting your like terms works for you, do that. Like, you could even underline them, box them up. Like, I've seen some students like circle and then do triangles and then squares and then maybe like a squiggly one or something. Or they'll underline them, or they'll like color code it. Whatever makes sense to you, I want you to do that method so that it just helps you keep these things kind of organized. So 3x squared and a -x squared should have been 2x squared. -2x and -2x is -4x. And then bring down that -4. So this should have been your answer for the first one. For the second one, don't let the size of it make you think that this is going to be any different or harder. You know, sometimes students see this big long one and they automatically think like I'm throwing them for a loop here, and I'm not. They're just adding more terms here for you to deal with. So I would have started first by rewriting it. Remember, all those terms in that second set should have changed signs. Okay, and then I started looking for like terms. I always start with the biggest exponent I see, so that's that 5x to the 4th, and I actually don't see any other 5x to the 4th, so that's going to be the only one that I kind of highlight in yellow. Then I've got x to the 3rd is what I would look for next, which I only see one of those, 6x to the 3rd, and it's actually minus 6x to the 3rd, so I would make sure you color that negative sign with it. Then I look for x squareds. I see 3x squared and 4x squared, those go together. Then x's, so -x, -2x, and it's like I need another color of a highlighter. Let's see what orange does. 2 and 7. Okay, so now I've got 5x to the 4th. Nothing else is highlighted in yellow, so I'm just going to bring that down. Then I bring down the minus 6x to the 3rd. Again, that one's all by itself. Now the green ones, the x squareds, 3x squared and 4x squared would be 7x squared. -x and -2x would be -3x. Again, watch your signs there. I would maybe see a student write like -x or something. They would make a mistake there because of those negatives. And then last is 2 plus 7, which should have been 9. And there's your final answer.